So let's look at a new series, and this time it's going to be a more complicated one. So we're adding up terms that look like 2 over 4n squared minus 1. And once again, we're starting with 1, going up to n equals infinity. So, as usual, to decide if something is going to converge or diverge, I want to start by looking at those partial sums. So let's start with S1. Okay, it looks like in this case it would be 2 over 4 times 1 squared minus 1. That's going to be 2 over 3. S2. Okay, let's see, that would be 2 over 4 times 1 squared minus 1. And then we would also add what happens when I plug in 2. So let's see, that's going to be 2 over 3 plus 2 over 15. Well, that's not very pleasant. So that's going to be 12 over 15, which is 4 over 5. Okay, this is definitely looking more complicated. S3 would mean add up their first two guys and then also add what happens when I add in 2 over 4 times 3 squared minus 1. So let's see, that's 2 over 35. So let's see, that would be 28 plus 2, which is 30 over 35, which is 6 over 7. So a slightly more complicated pattern is going on here. If I want to find out in general what's going to happen here, then I could kind of guess at it, or I can figure out a better way to break this down. So what I want to do is refer back to what we learned about partial fraction decomposition. Okay, so I'm hoping that I can rewrite 2 over 4n squared minus 1 to be equal to something over the two factors. So actually, let's go ahead and factor that bottom. 4n squared minus 1 is a difference of two squares. So I could write it as 2n plus 1 times 2n minus 1. So I would be looking at something over 2n plus 1 and something else over 2n minus 1. So let's get a common denominator here. Okay, I would get a times 2n minus 1 plus b times 2n plus 1 over 4n squared minus 1. And that's all supposed to be equal to 2 over 4n squared minus 1. So let's see, I'm going to group together my n terms. So I've got 2an and 2bn. And then my constant terms, negative a plus b. So let's make a little system of equations here. If I pay attention to the n terms, 2a plus 2b on the right side is apparently equal to 0 because there is no n term. Whereas on the other hand, negative a plus b is going to be equal to 2. Alright, well I could use combination to solve this. So I would multiply the second one times 2, the second equation I should say times 2, and add it to the first. That would get me 2a minus 2a, 2b plus 2b, and 0 plus 2 times 2. Which means b equals 1, and if I plug that back in here, looks like negative a is 1, so a is negative 1. So what I just figured out is that I can rewrite this nth term. So instead of just saying that I'm doing the sum of 2 over 4n squared minus 1, I'm now going to rewrite with what we just figured out. I'm going to rewrite it as the sum of negative 1 and 1. So let's start with this guy. 1 over 2n minus 1 minus 1 over 2n plus 1. Right, there's my a, there's my b. Okay, so this is a different way of writing that original series they gave us, but it's going to make some things clearer. So if I start writing out my nth term here, okay, the nth partial sum would be if I start with 1 over, let's see, that would be 2 minus 1, so 1 over 1 minus 1 over 3. Then I would have 1 over 5. Yep, sorry, 1 over 3 minus 1 over 5. Right, this is plugging in 2 for n. And if I plug in 3 for n, 1 over 5 minus 1 over 7. And I would keep adding terms all the way until I get to, well, let's see, if I plug in n there, I would have 1 over 2n minus 1 minus, and I kind of ran out of space here, so let me do this on the next line. 1 over 2n plus 1. Now, here's what I want you to notice. We're going to see a bunch of stuff cancel out. Minus 1/3 plus 1/3. Minus 1/5 plus 1/5. Minus 1/7 plus 1/7. Minus 1 over 2n minus 1 plus 1 over 2n minus 1. all I'm left with is the first term and the last term. So this ends up being another example of a telescoping series. But I had to come up with a partial fraction decomposition so that I could see that it was a telescoping series. So if I combine these guys, okay, I could get him to one fraction, but honestly, what's the point? I'm really just interested in seeing what happens to the limit of this guy. So if I'm going to try to find the limit of these partial sums, well, let's see. If I do a direct substitution here, I get 1 over 1 minus 1 over 2 times infinity plus 1. 1 over infinity is just 0, so this guy converges to 1. So because my sequence of partial sums goes to 1, I could say that my series, so my sum from n equals 1 to infinity of 2 over 4n squared minus 1, converges to 1. So not only does it converges to the number 1. Now, coincidentally, all the sequences we've seen that converge so far converge to 1. That will definitely not always be the case. We'll see all sorts of different values we can converge to.